Welcome to Brain Power. Today, we are going to take a fascinating journey into history, revisiting the Massachusetts Institute of Technology entrance examination of the year 1869, more than 150 years ago. These were not multiple-choice questions, not plug-and-chug exercises, but genuine tests of algebraic reasoning, clarity of thought, and step-by-step precision. In this video, we will carefully solve each of these problems, not rushing through, but explaining every single manipulation and justification along the way, so that you not only see the answers but understand the deeper process. Let us begin with the very first problem. We are told that the variable e is equal to 8, and we are asked to evaluate a rather complicated expression. This is the kind of expression that tests not just substitution skills, but also understanding of order of operations and careful arithmetic. Let us substitute the value e equals 8 directly. The first part becomes 8 minus the square root of 9 plus 2. Now the square root of 9 is 3, so inside the parentheses we have 3 plus 2, which is 5. Thus, the first part is simply 8 minus 5. The cube root of 8 is equal to 2, because 2 multiplied by itself 3 times is 8. Subtracting, we get 8 minus 2, which equals 6. The square root of 4 is 2, so multiplying we obtain 6 times 2, which is 12. So the second part simplifies beautifully to 12. Adding everything together, we calculate 8 minus 5, which is 3, and then add 12, giving us a total of 15. Notice how each radical was handled carefully. First the square root, then the cube root, and then the multiplication. And the final result of problem 1 is 15. This problem, while straightforward in hindsight, would have tested whether the student could manage radicals and order of operations without error. Now let us move on to the second problem, which is more symbolic. At first sight, this may look complicated because of the nested brackets, but the essential skill here is to expand each inner term and collect like terms systematically. We have the A terms marked in red and the B terms marked in green. We use the properties of parenthesis to first bring the expressions outside. Using this, the A minus B inside the parenthesis changes sign. Then we flip signs of every term since they are multiplied by a minus sign outside. Now that we have these terms, we group the like terms together. So the red terms together and the green terms together. This results in 2A minus B, which is our final answer. Not so difficult, right? Now let us see what the third question is about. It is asking us to multiply two algebraic quantities and then divide by A plus B. Very well, so first step is to multiply the expressions, and then we divide by A plus B. The expression that we need to simplify looks like this. First, notice that the second term in the numerator can be factored. Write it as AB minus 3AB. Now we can perform middle term factorization on it. Now taking common and factoring, we see that we have AA plus B factor, which we can cancel. After this, it is simply a matter of multiplication. Again, group the like terms together, and we end up with the following answer. Question 4 is a bit tricky since it is not obvious at first sight how to reduce it. But notice in the numerator both the terms have a x cubed, and in the denominator both the terms are perfect squares. We use that to our advantage. Apply the formula for a squared minus b squared in the denominator, and in the numerator take x cubed common. The red terms cancel off, leaving us with the desired simplified form. This required understanding of algebraic identities. Now we move on to question 5. First, let us LCM both the terms on the opposite ends of the division sign. Now, by using the A minus B whole square formula, let us convert these terms. Now, we expand the terms using the formulas. In the next step, we shift the division sign to multiplication by reciprocating the second term. Now, let us expand and clear the terms to be cleared. 2 is taken as common and cut off in the last step. Thus, a square plus b square divided by 2ab is the final answer. Now we move on to the question number 6. This is a simple equation question. First, we multiply by the LCM of the denominators, which is 16. We cut off the denominators by the multiplication. Now we expand the terms. Then we collect all the x terms on one side of the equation and all the constant terms without a variable on the other side. Now we perform basic algebraic addition and subtraction. At the end, we send the coefficient of x from one side to the other by turning the multiplication into division. And thus we get the final answer. Now we move on to question number 7. As we can see, there are two equations here. First, let us take the first equation. Let us move 5y to the other side, and then move 7 to the other side as division. Now let us plug the value of x into the second equation. Now, let us solve the equation for the value of y by performing the following techniques as shown in the video. Now, we find the value of y as 19. Now, let us plug the value of y into the value of x. Now, we find the value of x as well. Thus, we have solved both the equations for the two variables successfully.